Let's look at three approaches to reducing loss of soil organic carbon. So soil SOC is kind of redundant, but nonetheless. Slowing carbon losses in agriculture typically relies on no-tillage, management of livestock, grazing, and fires. So we mentioned the example of Delhi, and crop residue burning happens a lot in Africa and South America as well. Plant species based approaches rely on the examples that include planting of cover crops, use of plant species with typically high root biomass, conversion from annual to perennial crops makes sense, but depends on the market demand, depends on whether they are cash crops or subsistence farming needs, and so on. Crop rotation using perennial plant species, agroforestry we talked about, and wetland restoration. We'll look at the potential for wetlands around the world based on a few parameters. So examples of annual crops of course include corn, wheat, soy, and rice. So these are staple crops, and many of the subsistence farmers obviously need to grow them, so they cannot just rely on perennial crops. So they can, on the other hand, rely on cover crops and other no-tillage fertilizer, livestock grazing options to manage emissions better and soil organic carbon losses better. Perennial plants such as alfalfa, grapes, artichokes, asparagus, and tree crops persist for multiple years, but we know that alfalfa is a very high water demand kind of plant, so growing it in drier regions may not be a good idea. Many of these things, the above ground biomass can be removed, but the below ground root system can regrow. That's what makes them perennials, right? So here's an example of wetlands being degraded. Soil subsidence in the Sacramento-San Joaquin Delta of California. Wetland drainage led to decomposition of soil organic matter, leading to the land surface to drop over time. So you can see the soil has become parched and cracked, and you can see that there is no indication of carbon, and the vegetation is very sparse and shrubby, low root biomass, and so on. Okay, not a good idea. So there are people, this is from showing how the soil wetlands have gone from 1965 to 2013 in terms of water levels, and here it is from 1925 to 1955 to whatever the date here, 1977. Okay, so that's not a good thing, right? So this paper estimates global wetland suitability with a model. Basically uses soil types, rain, temperature, groundwater levels, etc. to estimate where are the potential for wetlands. Not surprisingly captures the Great Lakes regions and some coastal regions here, tropical regions here, and colder regions here. So in general, natural wetlands occur where the groundwater level basically surfaces, and if they are not drained, like Florida is basically built on drained wetlands, they have lots of vegetation, good habitats for migrating birds, lots of species of small fish, shellfish, insects, pollinators, plus because there is always some level of water, the vegetation that grows and drops the organic matter often gets sequestered because there's not enough oxygen for microbes to respire it. Okay, so something that has to be considered as well. We looked at this already, looking at it again. Soil amendments which modify the soil properties, as we said, as opposed to fertilizer which directly tries to feed nutrients. And water management is important, and organic amendments like no tillage obviously help. Organic matter amendments include biochar. We mentioned this before. Basically, this is a pyrolysis process which converts organic matter into high carbon content. We will see. Composting, obviously, very important in terms of rich carbon and nutrients, and residue composting. So you can have urban and domestic composting as well as crop residue products being composed, and they go again into this that we looked in the last podcast of managing soil organic matter to improve air quality, water quality, and productivity. Okay, so this is all happening in the context of climate change. Obviously, this is showing nice work from NCAR. I didn't put it here, but Dai leads this kind of work. I think he has left NCAR by now, if I'm not mistaken. Nonetheless, this is basically taking the what is called the Palmer Drought Severity Index. Should be PDSI. I don't know why it's written. Palmer Severe Drought Index, maybe. Anyway, so the first EOF, which is a statistical analysis tool called empirical orthogonal functions, if you have a time series and spatial variability like we have here from 1900 to 2005, then it gives you dominant patterns in terms of explained variance. So here, this dominant pattern EOF1 is explaining about 6.7% of the variance, total variance, and the second EOF is explaining 4.9%. It is small because it is done globally, but if you go zoom in locally, the explained variance can be much higher. Okay, so the inhomogeneity obviously makes a problem, but nonetheless you can see the pattern here. For meteorologists, probably can see Indian monsoon core zone, West African monsoon region, and so on and so forth. So the first EOF here, this is the associated time series. So if you multiply this by this, you will get the total first EOF variance. And you can see that this is showing the trend here. The increase in drought index from the 1980s. So there were this was below the long-term average. So this is kind of an anomaly in that sense. There was some variability in the mid 40s to 70s, and then it's been stuck here. Okay, so there are regions where the drought severity has been increasing and becoming more frequent and more persistent. And the natural variability is captured here in the second EOF, which shows, for example, El Nino related signals. So you can in fact see many of the El Ninos here with what is called PDO, or the Pacific Decadal Oscillation, which is related to El Nino in some sense, but it's a lower frequency. El Nino happens 2 to 7 years. You can go and watch my other podcasts where I explain El Nino, for example. And PDO happens on 30-year time scale, and there is no clear mechanism for PDO, and people argue that it's just an indication of decades with more El Ninos and decades with more La Ninas and so on. Nonetheless, to the extent that pattern persists for decades, it has impacts around the world in terms of reducing or increasing the severity of droughts. Okay, so all the management we are doing, all the deforestation, land conversion we are doing, and the policies we are thinking about are happening in warming that has already been happening, and the associated impacts in terms of droughts. We mentioned droughts because they have a huge impact on land, carbon, soil erosion, and so on, as well as heavy rain events like flash floods. But droughts often leave like the Great Depression, for example, or the persistent drought over Syria, and so on, tend to have historical impacts as opposed to floods that come and go. Droughts can leave a scar for many years and have deep impacts.